So a plane has a takeoff weight of 750,000 pounds of force and four engines that generate a maximum thrust of 50,000 pounds of force. If the plane were to start from rest and accelerate to takeoff speed of 180 miles per hour, and all four engines are operating at 75% of their maximum thrust, how long in seconds will it take to accelerate from takeoff? So first things first, we have weight. And weight is a form of force due to gravitational acceleration. So we have to get the 750,000 pounds of force and convert that to mass. So we have our gravitational acceleration, which is going to be 32.2 feet per second squared. We're going to go ahead and plug that into F equals ma. We have the 750,000 pounds of force equal to mass times our 32.2 feet per second squared, which is our acceleration. Now, when we plug all of that in, we get 23,292 pounds. Now, it's just going to stay pounds because we're working with US customer units. Okay, so we got our mass. Now we have to find our speed. So we have 180 miles per hour. That's our velocity, but we don't really like that miles per hour. So we're going to convert that to feet per second. So we know that 1 mile equals 5,280 feet. So we can go ahead and cancel out the miles. And we have feet over hours. Cool. And now we know that 1 hour equals 3,600 seconds. So we can go ahead and cancel out the hours. And now we have feet over seconds. When we plug everything in, we get 246 feet per second. And that's going to be its takeoff speed, right? So now we're looking for how long in seconds does it take to accelerate? So we're going to need to find acceleration. So what's accelerating the rocket? Well, it has four engines, and that generates a thrust of 50,000 pounds of force. So each of the four engines generate 50,000 pounds of force. So we're going to go ahead and do four for the four engines and times that by the maximum thrust force, which is 50,000. And now over here, we have all four engines are operating at 75% of their maximum thrust. So we're going to go ahead and multiply everything by this 75%, so 0.75. Now when we plug that into a calculator, we're going to get 150,000 uh, pounds of force. So that's going to be our total force that's pushing the plane. So now we have this force, right? And we know that F equals ma. So we can go ahead and plug that force into F equals ma. So 150,000 equals our mass of the plane, which is the 23,292. 23,292. And we're going to go ahead and multiply that by acceleration. And what do you know? We can solve for acceleration now. So we're going to go ahead and divide the 150,000 by 23,292. And we're going to get acceleration equals 6.4. And of course, we're rounding a little bit. So it's going to be feet per second squared. So now we know that time equals change in velocity over change in acceleration. Now, in terms of units, it's going to be, let's see, a velocity is going to be feet over seconds. And because we're dividing, we're going to take the inverse of acceleration. So that's going to be seconds squared over feet, right? And when we cancel out the units, we see that the feet cancel and one of the seconds cancel. So we're left with seconds. which is time. So what we can do is we can go ahead and do change in V over change in A. I'm going to go ahead and set that equal to 10. And we can plug in our 264 feet per second. And we can go ahead and plug in our 2.44 acceleration. When we plug that into our calculator, we get 264 divided by 6.44, and we get 40.99 seconds. 99 seconds. And that is our answer. Now, when we plug that into our calculator for a more precise answer, we have our velocity, right? The 180 miles per hour, and we're going to do it times this. So we know that there are 5,280 feet in 1 mile. So we're multiplying that by 1 hour over 3,600 uh, seconds in 1 hour. So that's how we got the 264, which is exactly what we got. And when we get our acceleration, we have our force right here, and we have our mass right here. So then we're going to go ahead and do t equals velocity over acceleration, and we get our answer, which is 40.99, which is essentially what we got. Cool.